So we're going to use these two functions. The first one says literally just add them together. Basically, like make sure you're paying attention to your notation so you don't do the wrong thing for the problem. I can't really do partial credit if you do the wrong thing, you know. All right, so you're just adding them together. 3x squared doesn't have any like terms, so just 3x squared. You'll have minus 4x plus x, so minus 3x is just literally adding things together. And then 7 plus 5 is 12. Now, when you're subtracting, I strongly recommend writing out the middle step because negatives are the most commonly missed thing ever. We're going to write f of x, so I'm basically just going to copy this first function there. So like, hey, Miss Cole, it looks like you just rewrote it. Sure did. And then you want to do minus g. So you have to distribute a negative to both parts of that. So because you have to subtract the whole thing. So it's going to be minus x minus 5. And then you just put the like terms together. So it would be 3x squared. And then what? Yeah, minus 5x. You guys talk a little bit so it's not me just talking at you. No one likes to be lectured at. All right, and then what? Yeah, plus 2. Cool. Now that was f minus g. When you go to do g minus f, you can take that answer and just negate the whole thing. It's just the opposite. So it'll be negative 3x squared. And then what? Yeah, plus 5x minus 2. So you're just negating each of the terms.
If the x plus 5 is like already negative x minus 5, would it?
Then they would become positive. Yeah, it's opposite. All right, this one means we're multiplying. So there are a bunch of different ways you can do this. Here's what I'm going to do. I'm going to take this x and distribute it to the whole thing. And then I'm going to take this 5 and distribute it to the whole thing. It's going to be about yay long. And how many terms will we have in a row? 6. Good, because this one has 3 and this one has 2. So 3 times 2 is 6. All right, so if we distribute an x through there, it's going to be 3x cubed minus 4x squared plus 7x. Just distributed an x. Now I'm going to distribute a 5 through there. So that would be 15x squared minus 20x plus 35. And then you just do your like terms together. So that would be 3x cubed isn't going to go with anything. And then what? Yeah, good. Plus 11x squared. And then, good, I heard somebody whisper it back there. Minus 13x plus 35. This is all just a review of algebra 2. All right, and then the last one of those, you are dividing. That is actually new, something you learned this year. It's your synthetic division. You're going to do this divided by x plus 5. So what number goes in the little box off to the side? Yeah, negative 5, good. And then you're going to steal all your coefficients from the problem. So 3, negative 4, 7. Will the remainder necessarily be 0? No, it's just going to come out to whatever it comes out to. So don't, be worried if it's not 0. So you're going to multiply, add. This will be negative 15. Add, you get negative 19. I know when I multiply these, the negatives are going to cancel. 19 times 5. You could either do 20 times 5 in your head and then kind of readjust it, or you could do a little side problem. Again, a 2-digit times a 1-digit is fair game without a calculator at this level. Okay, so I would just work this off to the side. 9 times 5 is 45. 5 times 1 is 5, plus 4 is 9, so 95. But again, that's fair game. That's an allowable problem. And then we're going to write our answer. It'll be, oh yeah, I'm sorry. That's not the remainder at all. 90, thank you. Looking out for me. 95, and then you have to add 7, so 102. Thank you. Sorry. Crisis averted. All right, and then you go to write your answer. It'll be 3x minus 19. And then how do you tack on that at the end? 5. Good. Perfect. That's your answer. Lovely. All right, then we're going to get into the domains. These ones are a little easier. The ones on the back page are the ones where it gets, a little spicy. All right. So f plus g of x, we're going to write out our domains for each of these individually, and then you just put them together. You just basically follow both rules at the same time. Now this one is a squared. What shape graph is that going to be? Yeah, a U shape, a parabola, right? So what's the domain of a parabola? Yeah, all numbers. All reals. Now, this one is like, you have to be this tall to ride the ride. You have to be 2 or above. So how do we write that? Does anyone remember? You want to be 2 or greater? There's a 2. We do interval notation here, guys. Thank you. And then what does 2 get? Bracket. Good. Because you can plug in 2, because 2 minus 2 is 0. And what's the square root of 0? Yeah, 0. You can square root 0. It's just 0. You're going to be 2 or above. All right, so if you put those together, this one doesn't have any rule with it, so you sort of ignore it. If you put them together, you just get 2 to infinity. If one of them's all reals, you basically just ignore that. Let's try it again. Who's your troublemaker for this one? 4. You're going to leave out. Does anyone remember how to write that? Let me just check, because the other one was a little. Good, perfect. And then 4 to infinity. Nice job. You're leaving out 4. This would be a line, so all reals. A line goes forever both ways. That's your good old y equals mx plus b. So again, this one doesn't have any restrictions. It's like everybody's invited to the party. So we're going to kind of ignore that. If you put these together, 4 is just your troublemaker. So if you put them together, that is your answer. And then this last one, they both are going to have a restriction. So you'll see what it looks like if you just basically do both things. Who's your troublemaker on this one? Yep. Kick out -6. He is causing problems. And then this one is like, you have to be so tall to ride the ride. You want to be what number and above? Close. Good. -10 to infinity. So if you want to follow both of those rules at the same time, you want to be -10 onwards, but also skip over -6. So it is going to look like this. It looks like a bunch of you wrote it ahead of me, which is cool. Make sure your answer's right. It'll look like that. Did you guys see how we just put them together? It's just like both things at the same time. All right. That all usually goes well. That's fine. Are you okay?
Yeah.
All right. So here is our composite functions. We're going to use F and G to answer the questions. I really want you to write the middle step on these. I know it's like, oh, Ms. Cole, I can do it in my head. Yeah, but I can't give you partial credit if you make a mistake if you don't write the middle step. Do we start with F or do we start with G? Do you remember the telephone game? Like that. Okay, so we're going to do G of 0. G of 0. If you plug in 0 to G, what is your output? -3. Do you see that there? -3. So you're going to pass that along like the telephone game and do F of -3. Now, if you don't want to draw the little arrow, that's fine. I'm just doing that to show you that it's like the telephone game. But I would like to see this step. Because again, if your final answer is wrong, I can't do partial credit if you didn't, write anything for me. So now we're going to plug -3 in here. -3 cubed, that is one that you need to know. It will be -27, good. Double that. -27 doubled be -54 plus 1 will be -53. That was a little tough. Let me talk you through it again. -3 cubed is -27. If you double that, it's -54 plus 1 is -53. All right, which function do we start with on this one? F, good. F of 2. 2 cubed. 8, double that. 16 plus 1 is 17. So you're going to take 17 and plug it into function G. So if you plug 17 in here, 1/4 times 17 is 17/4. Please don't overthink that. 1/4 of 17 is 17/4. It doesn't divide out nicely. Now -3. I need a common denominator. So here's the $1 million question. Oh, before I could even ask it. How many fourths is a whole 3? And it is 12. You can think of it as 12 divided by 4 is 3, or 3 times 4 is 12. But you guys said the answer here before I could even ask it. All right, and then subtract them, you would get 5/4. Good. And then this one, you're going to use the same function. It's sort of like cannibalistic here. F of 1. If you plug in 1 cubed, 1. Times 2 is 2. 2 plus 1 is 3. So we're going to do F of 3. I feel like we already did that one, right? Oh, well, we did -3. All right, if you plug in 3 cubed is 27. Double that is 54. plus 1, 55. And then these domains is the thing that we did last time, okay? But to calm you all down, here's my pep talk. If you struggle with getting the domain of the composite function, that's the hard part. How many blanks do you see are the domain of the composite function? Let's count them. 1, 2, 3, 4. Out of how many blanks do you see there? Do you see how that's a very small portion of what we're doing? So even if you struggle with the difficult part, there's enough other answers. Here, let's do the rest of them. You'll be like, hey, it'll calm you down. Like, hey, I answered a whole lot. What would be your domain for this one? Yep, -5 to infinity. How about this one? All reals. Here, let's just go to the next one. Who's your troublemaker here? 2. Leave out 2. Do you see what I'm saying? Like, if you just answer all the simpler ones, you'll be like, hey, look, I answered most of the quiz, and it will calm you down. How about g of x? Yep, all reals. It's a line, so everything. This is another quadratic, so all numbers. Yep, 9 to infinity. You need to be 9 or taller to ride the ride. Yep. Yeah, and again, the domain of the composite part is the tricky part. But even if you struggle with that, you can still get a lot of points. Like always, the topics we do in pre-calc are difficult, but the way I grade it is pretty forgiving. So like, yeah, you need to know your stuff, but it's not going to destroy your grade either. All right, and an absolute value is all reals. Yeah, because it's a V shape, so it goes forever. So look, we answered half of it already.
Is it all gonna be? No.
Yeah, is there gonna be the one where both of them?
So on this line, we're going to put f of g. You're going to plug g into f. So it's going to be a big old square root. Underneath, I'm going to kind of talk you through this because we don't have a lot of space. Underneath of it, you would have x squared minus 3 plus 5. Here, I'll show you what it would look like. It would be x squared minus 3 plus 5. What is that going to be?
X squared plus.
X squared plus 2.
Without the yeah, no, yeah, you plug it in.
You're taking this x squared plus 3 and replacing the x over here. So underneath of your square root, you have x squared minus 3 plus 5. Now, can you cancel out the squared? No, it's not on the whole thing. Okay, here we go. Which one's the inside? G. Does G have a restriction?
No.
No. Great. If it did, though, we would keep it. We keep it. All right. If the inside one has a restriction, you keep it, but this one doesn't.
Inside keep, out.
Yep, that's what we said. Inside keep, outside problem. Does the outside one have a restriction? Yes, that's where you set up a problem. You're like, hey, g of x, you better stay bigger than -5 or else no dessert. You remember that? Hey, g of x, you better comply with this rule. So we're going to take g of x, this x squared minus 3, and say, hey, you better stay bigger than -5 or else you have to follow this rule. Now, don't try to force that to come out to anything in particular. You're just going to see what happens. What would you do next to start trying to solve it?
Move the negative.
Yeah,
3.
well, you would add 3 to both sides. So you'd get x squared greater than or equal to -2. And then you would stop and you would go, hey, when I square a number, it will always be positive. So this is always going to be bigger than -2. Do you understand what I'm saying? Always positive. So you get all reals. That's the situation like when your parents come hounding you and they're like, hey, do your homework. And you're like, I already did it. Geez, like you're already in compliance. So it's all good. Do you get what I'm saying? They come in and they're like, clean your room. And you're like, I did it already. Geez, like, so if you square a number, it's always going to be positive. So it'd always be bigger than -2. Like it's always.
If equation works out,
You always write all the numbers?
I thought
Unless if
-5.
the inside one
Yeah,
also had a
that's
restriction, in which case you would keep that. But again,
If it did, and if it wasn't in compliance, then you use the outside.
yeah, here, I'll show you. We're going to do another one, guys. All right, so here, G gets plugged into F. So this X plus 8 gets plugged in over here. Here, I'll show you what it'll look like. It'll be 1 over X plus 8 minus 2. And so that would be 1 over what? X plus 6. Now, the rational ones, I kind of just encourage everybody to look for the troublemaker because it's a whole lot easier. Who's your troublemaker for this? Yeah, so I wouldn't even go through, like, I wouldn't go through trying to set up a problem or any of that. I would just go, hey,
So-
-6 is the
If-
troublemaker.
Simplifying and there's a, I mean, it's irrational and you just exclude the troublemaker in this room.
Yeah, you just leave it. Like, you would just copy that one over. I think this one's gonna turn out that way. Let's see. Taking G and plugging it into F. I try to make them all a little bit different. So when you guys are asking me these questions, it's like I'm probably going to answer it in one of the other ones. I try to make them all turn out different. So this is going to give you square root x minus 9 squared. Here, I'll show you what that'll look like. And then plus 6. Just took this, plugged it in over here. Now those are going to cancel because why? It's on the whole thing. So you end up with x minus 9 plus 6, which would be minus 3. Good. So which one's the inside one? G. Does G have a restriction? Yes, that means we keep it. We keep it. Does the outside one have a restriction? No. So you do not need to set up a problem. You just keep this. That's your answer.
Yeah.
Here's what you guys came up with last time. This is what you guys came up with, but I realized it was a week ago. Inside, keep. Outside, you set up a problem. That's what you guys came up with last time. So that's what I threw.
Wait. So, when you make the problem.
If the outside function has a restriction, you set up a problem.
Like, when you do the-
If it's anything that's not all reals, that's some sort of rule.
That's why we did the problem.
Correct. And for number 11, we could have done a problem as well. But I usually, like, you see on number 11, the outside one has a restriction?
Yeah.
But I usually, it's a lot easier to just do this. But here, I'll show you what the problem would have, here, everybody listen to me. I'll show you what the problem would have looked like. It would have been, hey, G of X, you better not equal 2. I better not see you hanging out with 2 because 2 is a troublemaker. It would have looked like this. X plus 8 is not allowed to equal 2 because do you see how 2 is the problem? Well, if you solved that, you would get X can't be -6, and that's what we did. But usually it's easier to just not even do that and just go, oh, -6 is the troublemaker, but you could set up a problem.
Okay, so we've been saying about.
Yeah,
If you have to use that, like, equal not only be rational.
yes.
Okay, so
This
it's
is
just
for
easier
rational.
to just do
Since if
that.
we keep it, we don't have to make a problem, it's just 9 to. Oh,
Yeah,
wait,
you just
that's
keep
not
it.
hard.
No, it's not. Okay, let's try this one. G gets plugged into F. So this gets plugged in over here. It's going to look like this. I'm going to say the whole thing because it sounds like gibberish if I say it, but you can't combine the -2 and the -3. Why not?
Because one of them is inside.
One of them is inside. Basically, if you see an absolute value, you cannot combine any. Just, which is great because then just do nothing, right? Okay, does your inside function have a restriction? No, great. Does the outside one have a restriction? That's where you set up a problem. Hey, G of X. Hey, G of X, you better not equal 3 or else. I better not see you hanging out with 3. 3 is a troublemaker. Now, this is a review of algebra 2. When it's an absolute value, you would say X minus 2 can't be 3 and X minus 2 can't be -3. The reason for that is an absolute value is a distance from 0. Pretend this is a number line and I'm standing on 0. How can I be 3 units away?
Both sides.
Yeah, I could go to -3 or I could go to +3. So like, that's why it's both of them. Now, what would you do to start solving this one? Yeah, so X can't be 5, and then this one, X can't be -1. Now listen, if you were like, hey, Miss Cole, I didn't really like that. If you sit there and ponder long enough, you can come up with those two numbers. Look, what is 5 minus 2? 3, and then 3 minus 3 is 0. Now let's do -1. -1 minus 2 would be -3, but if you absolute value that, it is 3 minus 3 is 0. So if you sit there long enough, I believe you're all really smart. You could come up with those two numbers. Let me finish this thought and then I'll answer that. Now, when you skip over them, which one are you going to skip over first? Yeah, -1. So you're going to leave out -1 and you're going to leave out 5. So again, if you didn't want to set up a problem, I think if you just sat there and thought about it long enough, you would come up with those two numbers because it's really not that hard. And that's what a lot of people end up doing.
Okay.
Because I see them have the right answer on their paper with no work. And usually I don't like no work, but in that case, I'm kind of like, You probably just sat there and thought about it, you know what I mean? Hold on, let me answer this other question.